cannot fit a newly designed school building onto a standard piece of paper. To draw massive real-world structures, you have to shrink them while preserving their exact geometry. Looking at this floor plan, you can see how a mathematical scale makes this possible. It is the tool that maintains the true proportions of an object while drastically reducing its visual footprint. This diagram compares the two core types you will use. On the left is a plane scale, built for measuring 2 units, like meters and decimeters, to a single decimal point. On the right is a diagonal scale. By adding a vertical axis, it divides those units further, allowing you to measure 3 units to 2 decimal places. Mastering these lines and grids is how you communicate exact, buildable dimensions in engineering and architecture. Let's solve a standard technical drawing problem. We need to construct a 1 to 50 scale capable of measuring up to 6 meters and use it to mark a specific distance of 4.6 meters. Step 1 is identifying the representative fraction, or RF. This is the unitless ratio of drawing size to actual object size, which the problem gives us directly as 1/50. Step 2 is calculating the length of scale. This is the physical line you will draw on your paper, found by multiplying the RF by the maximum length to be measured. This equation shows a common trap. Before multiplying, convert the maximum length of 6 meters into centimeters so it fits on the page. 6 meters becomes 600. 1/50th of 600 gives exactly 12 centimeters. Drawing this 12-centimeter line perfectly represents a 6-meter capacity. Next, we plan the construction. To measure up to 6 meters, we divide this line into 6 equal blocks. Each segment represents exactly 1 meter. The 0 mark drops in at the first internal tick whack. From there, label the whole meters, 1 through 5, moving right. That leaves a single empty block to the left of 0. We divide it into 10 equal parts. Each small division represents 1 decimeter, or 0.1 meters. Looking at this layout, where would you place your marks to show exactly 4.6 meters? Placing the 0 mark internally is the only way a single flat line can measure whole units in one direction and decimal subdivisions in the other. To plot 4.6, count 4 major divisions right of 0, then count 6 minor subdivisions left. The total span is 4.6 meters. To measure hundredths, this same base extrudes vertically into 10 lines, connected by diagonals, utilizing similar triangles for extra precision. Reading any technical scale relies on this bidirectional rule. Whole units step forward, fractions step backward. To solve these problems accurately every time, use this checklist. Calculate your RF, convert your units before finding the length of scale. Drop your 0 after the first division, and map your decimals from right to left. For full access to class videos and practice problems, visit the Yaka Digital Network website. Follow these steps, and the math you perform on a flat sheet of paper will perfectly dictate the reality of the structures you build.